Okay, switching to English. So we are done. Our main part, the talks are over, but we have the Q&A session. So we have promised to have it, and I'll need to ask our speakers to get to the stand again, and we'll give the chance to the audience to ask questions. Meanwhile, well, we can also have some conversation, like I'll be asking some questions. Sandeep, can you please join? I think that English will be the working language because we have foreign guests also. And I can translate the questions, just in case. It doesn't really matter, but okay.
I have two questions. First is, can we have the presentation slides? And the second is, do you going to give some tools to our educational centers, for example, universities or other centers, for students for their trial use, for example? Thank you.
Okay, thank you. So concerning the presentations, yes, we are going to share them. And concerning the second part, I guess it is a question for our speakers. So are you going to provide any tools? You mean like programs or hardware or both? Both, okay. So are there any plans for such a cooperation with any universities, or maybe you already have? Can you
Actually, as about Siemens CDA, I know that from previous company, from Mentor Graphics times, we had such a tradition to supply our tools to universities for trials, for trainings. I believe that this program should exist now. I'm not sure. This is actually a question to our managers, but I believe it's possible. And yeah, Siemens CDA should be able to provide some software to universities for training.
Thank you. Anyone else? Do you have any answers? Like, yeah, okay.
Yeah, I can speak for Nvidia. We are already working with at least Yerevan State University, and we're giving them lectures, quite technical lectures too. About I gave one recently about kind of like algorithms sample platter, so to say. What kind of algorithms we're using at Nvidia, not just in Omniverse, but in some other projects that I worked on. We are open to collaborate with educational organizations, both in terms of hardware and in terms of software. And with Omniverse especially, we have many different ways to cooperate, because Omniverse encompasses AI and movie making, for example. We have a great example where one of the Nvidia employees is also a professional movie maker, and he is using our tools that you probably have seen today that I showed to teach composition, like camera composition when you do movies, to his students. So that's just one example, and I can totally see similar possibilities here.
Okay, thank you. Yeah, we have one more answer, or even two.
If I'm not mistaken, actually, Xilinx was participating to training sessions for Slavonic University students, and it was I know this was quite useful for the students, and it took a couple of months, right? If I'm not mistaken,
details.
Two, 3 months. And during, actually, that's not only Xilinx, the Siemens also, and other IT companies. And as far as I know, I might be mistaken, but Xilinx is collaborating with Seagate for several training groups, like organizing trainings for FPGA embedded systems and so on. And we are trying to, actually, we are new in Armenia, so we're trying to gather more and more students and interested person to the lectures, and maybe some programs will be in the future.
Are you going to provide those $60,000 FPGAs for education?
No.
Okay, thank you.
That's for dedicated. Actually, that's it's not mass produced. So that's for special reason, for special application.
Joking,
for education, I think the $100
yeah,
FPGAs
they will
is
be
enough.
enough. Yes, I see. Thank you. Sandeep?
I'll keep the answer short. Yes, we do have university programs. If you want to try out our software, just let us know.
Yeah, thank you. Yes, so turns out that most of the companies are doing something in education and including their tools, right? Great, thank you. Yes, one more question.
First of all, I would like to say thank you to our organizers of this conference and also speakers for very useful and essential information. First question is concerning to our conference. Since the context of our conference is system programming, I would like to ask the speakers what is their, what they think, what is the level of system programming development in Armenia, how much it is developed, and what steps need to be done. What is the tendency for developing? Are there any limitation process that stops the process of development? First of all, and second question, in the context of making career in system programming in Armenia and in abroad, how they assess, is it good to make the career in this field, or there needs something to be done? So in Armenia it will be more attractive to make career in this field. Thank you.
Okay, thank you. Thanks for the feedback. And yes, please, do we have them? Okay.
Thank you for the question. System programming and compiler technologies are becoming very popular in Armenia, and there are several problems regarding to career in this field. You need to learn longer than in other fields. So usually our students starting to work from second grade bachelor, and they don't want to put more effort in this field, and usually maybe 5% of all students continue their education and becomes specialists who can work on this field. This is the problem, but the good thing is that in Armenia we had some research groups and projects that are currently active, and so we have initial number of specialists who can prepare such students, and Russian Armenian University has a special strategy to prepare such students, and basically we take students from the second grade and provide them a very high scholarship, so they don't want to go and become web developers or something easier. And after continuous learning for several years, we provide such specialists, but we need to understand that the capabilities of one university are very low compared to the need that industry has. So there we need to work together with industry to provide such specialists. And to do that, we already started joint specialization, which is delivered for last 3 semesters for the students, and we hope that it will allow us to increase our capabilities regarding to such specialists. So that's all. Thank you.
Thank you. Any other answers? Okay.
Thank you. It's indeed important question. There is a high demand in Armenia for programmers, for software developers, due to existence of such specialists, Armenia is now it's represented in this market of high technologies, particularly in electronic design automation, which I was trying to describe. But what I was trying to emphasize during my talk is that it's not enough to be just a good software developer. For current technologies, for current demands, there is need for special, for example, in numerical methods. So we need developers with good knowledge of mathematics, of different numerical methods. And also it will be good if these developers will have some basic knowledges in physics, because current technologies are developing so that all these softwares are becoming based on physical models. So yeah, I just want to emphasize that it's not enough to be good software developers. Some basic knowledges in fundamental science, in mathematics, in physics are required.
Thank you. And what about the second part of the question? Can you please repeat? Maybe we just got out of context.
Okay, I would like to. I just asked what is the from the perspective of making career in this field. I would like to ask how is it? What problems can actually candidate face? For which kind of problems? And is it attractive in Armenia to make a career in this field, in system programming?
Yeah, let's say except of the duration of the learning, right?
Yeah.
You mean?
Sure.
Okay. Do we have any answers? Like, yeah, sure.
I'll try to answer from two perspectives. Now, philosophically speaking, system programming, people who are trying to learn system programming professionally, grow a career out of it, are challenged, in my opinion, more than other people, like, I don't know, UI design or AI or something like that. Now, why it's philosophical? Because I believe if you are really interested in this, you will find your place. And you will build your career out of it, and there will be no problem. Now, if you give up, then of course, yes, you've challenged yourself for nothing. So don't give up. But practically speaking, I think there is this interesting balance, right? Because there is not a lot of really good system programmers out there. Not just in Armenia, everywhere, really. And so when you need one, when we need one, we tend to search for a really good system programmer way more than for other disciplines. And so that's one of the reasons why you should, why you can believe that this is a good career path.
Can we somehow translate it into numbers? Like, are the salaries competitive? I mean, can we make any comparison? Like, are system programmers paid the same or more in comparison to, let's say, web?
I can answer again for Nvidia, and then
yeah,
I'll let others. But at Nvidia, we really don't care all that much about the discipline. Mm-hmm. There is like levels, career levels that are assessed during the interview, and then you can grow, of course, but it's not like at Nvidia system programmers get less or more than at the same level than UI expert or I don't know, like AI researcher or something like that. Now there is a difference, of course, between personnel, but we are still talking about engineers, and between engineers there is not much difference.
Okay, thank you. Any other answers? No. Okay, thanks. Thanks for the question. Anyone else? Yes? Okay.
Hello, everyone. I have a question for Dmitry from Nvidia. In your presentation, you mentioned that you will try not to use constructs like STD, STD string or something like that. But also, my question is, like, doesn't static linking solve that? Now I'm not a C++ expert, but that part was a little confusing. Can you elaborate?
Oh, sure. Yeah. So the idea, I'll remind that the idea is that multiple teams are building their reusable modules that are, and it's a key thing, they need to be dynamically loadable. It's a plug-in-based architecture. The entire Omniverse, all of the products are these tiny DLLs that are loaded dynamically. So we cannot really, link a giant application, everything link into it statically. That's one. But even if we were to try this, the problem is that you build your library, let's say structured logging library, for example. You build it as a static library. And you have like a header and a .a file, for example. Now you've built it with GCC 9, for example, and I'm trying to use it with GCC 10. Now, I don't think this is actually the case in this particular situation, but it could be the case that the definition of STD string has been changed between GCC 9 and 10. And best case, my application will simply not link with your static library, so that won't work either. So that's why we depend on really stable C ABI, built-in types and whatnot. And honestly, it's not that big of a deal. It actually, there is even an advantage in this. It keeps us minimal in the interface. It restricts us from using like monstrous structures like STD unordered map from string to a vector of tuples or something like that. Because when you unleash this beast, it's very easy to overuse it.
Yeah, and at the end you can serialize everything to a byte stream, right?
Sorry, what's that?
I mean, you can just use byte streams to simplify. I mean, at the maximum, just no types.
Oh yeah, yeah.
That's just joking. So yeah, did we answer to the question? Is it okay? Yes. Thank you very much.
First of all, let me thank you all for your time. It is very important to have these kind of events in Armenia. So I have two questions. First one, you all talk about the collaboration with the universities, but it was mostly concentrated into preparing an employees for your companies. Do you have any fundings for the research programs? Because we kind of see that we are reaching to the potential, the maximum potential of the transistors, and it seems that we are in the place when we need some kind of breakthrough, some kind of invention. Are you working with the physics faculties more on the research programs? And the second part is, as we have representatives of the biggest companies in this field, where do you see this technology moving forward? Meaning that we see that transistors, we cannot make them any smaller. Where do you see our future in this field? We saw some experiments, but I want to hear from you as well. Thank you.
Thank you. Who is going to answer? Yeah, looks like no research is being done.
I am not from the industry, but I can partially answer the question regarding to research budget. The Siemens has such budgets, and currently we had a joint project which is performed in Russian Armenian University, and as well I know that this budget not for just Russian Armenian University, but for some other universities as well, but it is regarding to software part. So regarding to physics and other things, I don't have any answer.
Do you know the topic? Maybe it can help with. I mean, is it a research, right?
Yes, it's
Sure.
research, so they have a separate funding, and this is regarding to placement of different structures in chip. So I cannot say much detail because I'm not involved in the project, but I know that it is an ongoing project.
Thank you. So Siemens is doing some
Yes,
funding.
indeed, Siemens have a budget for collaboration with universities, but I think this is not what you had mentioned, because generally these projects, the aim of this project to outsource some research, which should be what we need, and to outsource it to universities. But for now, we don't have such projects to finance some research in general, such as development of new transistors, maybe new quantum effects, so on. Yeah, this is not what we can provide for now, unfortunately.
Thank you. So maybe this is the case with Armenia. I mean, because we don't really have that culture of. I mean, so you were talking about collaboration with physics, right? Faculty of Physics. So maybe we don't have enough physicists able to do that research. That's why we don't have the funding. Maybe it's vice versa.
I mean, I think the main problem is that the companies which are represented here, these are mainly software companies. They are interested in software development. If you are talking about development, for example, of some transistors models, development of new transistors, this is mainly the topic of fabs which produce these chips or which develop design. Since this industry is not represented in Armenia, there is no currently funding for such projects.
Okay, thank you.
Unfortunately.
Yes. Do you want to answer? Yeah. Can you please pass?
Yeah, regarding actually the first question. So I will not say for Xilinx, but we should understand that that's the problem of our country. So the main IT companies are just the software companies. So from terms of hardware and physics, it's very, very hard to get the design done in Armenia. Actually, the only company I know is Synopsys. They are doing IP design in Armenia. So that is making the problem to organize this kind of the outsourcing to the universities and getting exactly the hardware and some designs regarding the physics. If it might help you, I can say for what I know, for example, in South Korea, in Samsung, actually there are a lot of Armenian students which went to the South Korea for studying, and they are doing a joint project with the Samsung actually. If you wish, I can give you the contact. So that's not migration, actually that's just guys are studying in the university in South Korea, which are regularly working with Samsung, and Samsung outsourcing a lot of projects there, and it's very interesting for growing perspectives, and so that's particular for physics.
Yeah, so we have the potential, right?
We do have, and it's not a short story, it's a quite long story, about 10, 15 years.
Yeah.
And there are professors which are collaborating with, especially with semiconductor physics in Armenia University, with students, and they just very occasionally traveling to Korea, and yeah, we have actually. and and we grow a lot of good engineers during this, and they are now, unfortunately, most of them not working in Armenia, but yeah, from professional perspective, they are growth in the real project, the real outsourcing with Samsung.
Yeah, so it turns out that Samsung is doing the research part, but unfortunately Samsung is not here. So we need to take it here, right? And
that's a country problem, I think. It's a global problem. We are living in Armenia. Samsung is just has a big budget, like 10 times, maybe 15 times bigger than Armenia.
Yeah, sure.
So that's the reality.
Yes, sure. Thank you. No more answers, so let's get to the next question.
I would like to speak about the Moore's law, but not from the perspective of physics, but biology. In 2015, the Manchester University developed the DNA computer, the so-called. If you perhaps know that 1 gram of DNA could contain 200 petabytes of information. How about do really disruptive things in Armenia in collaboration, for example, with the Armenian Institute of Bioinformatics, which was set up recently. And how about cooperation with or collaboration with the leading foreign universities, for example, with the Manchester University, to develop such computers and such technology in collaboration with scientists and software engineers in Armenia? I would like to hear your answers, because it's very, very cutting-edge technology, which could be, even could surpass quantum computers, prone to doing errors. You all know that quantum computers do errors, but DNA computer didn't do such errors. I would like to listen to your answers. Okay.
Thank you. So it's about biocomputers, right?
Yeah, biocomputers.
Do we do
DNA
any
biocomputers.
Is there any research that maybe you have heard of? Nope. No, looks like we don't have an answer, sorry. So, yeah, recently there was an Institute of Bioinformatics founded in Armenia, so they are really active, and probably you need to get in touch with them, because I'm not really sure what kind of research is being done there, but anyway, there can be. Sorry, we don't have an answer for your question. Yes, another question.
Բարև ձեզ, ես ուզում եմ հարցս ուղղել Գևորգ Օհանջանյանին, AMD-ից, ինչու օգտագործել Raspberry Pi, այլ FPGA ինչու օգտագործել, ոչ թե Raspberry Pi, մանրամասնեք։
In English, right? So the question is like, why not to use Raspberry Pi instead of FPGA?
Yeah, do you mean learning process or in general?
General, different. For using.
Well, if I'm not mistaken, Raspberry Pi is using Broadcom chip, right?
Yes.
Yeah. So everything is depend on a design. One answer I can give you is parallelism, because if you use CPU, you know, it's like doing one instruction after another, right? It's sequential. FPGA gives you ability to program chip parallelly. So they can do the same job parallelly. If you do the same job parallelly, you can significantly decrease processing time. That's one answer I can give you.
Thanks.
Thank you. Any more questions?
I have two questions. First one, you said at the beginning that it's the first conference of system programming in Armenia. Will this kind of conferences become more common in our country? And the second question is, the question is to Dmitry from Nvidia. Will Nvidia drivers become fully open sourced or no?
Okay, thank you for the question. So the first part, it mostly depends on the audience, in fact. So as you can see, companies are happy to be here, and speakers are spending their time describing, explaining what they do, and it mostly depends on the audience. And if the programmers are ready, they really eager to learn and want to know more about system programming, then yes, we can happily make it periodical. I mean, the conference can be periodical. And concerning the second part, yes?
Yeah, I'll try to address your question as much as I can, but my capabilities are limited here simply because I'm not in the driver team. The driver team is all in US, and we are much higher level. But I'll say what I know. So recently Nvidia released, let's put it that way, made the Linux driver more open source. So we've put in the published code base, we've put more that was previously closed. Now, as far as I know, some pieces, like important firmware pieces, are still closed. I'm not sure when this will become open as well. Sorry, I don't have an exact answer here. There are reasons to keep at least some pieces closed, but yeah, unfortunately, I don't have a precise answer for you when exactly this will become fully open.
Thank you. But so far we see some progress. That's
yeah,
that's
we definitely
good.
yeah. Like I said, recently we've made it more open source than before.
Okay, so it's getting more and more open source, and eventually we'll end up with some open source one. Thank you. Yes.
Usually, open sourcing the project has some, how to say, not obvious dangers. It's not about Nvidia, it's in general, because when you provide the source code, then you potentially provide hidden vulnerabilities that may become a reason for attack. So usually before becoming open source, you need to fix as much possible vulnerabilities as possible, then give the source, because source much easier to analyze and understand possible flaws.
Yeah, thank you for the comment. Fully agreed. Just as an example, the fully opened Intel's specs, if there were such a thing, the vulnerabilities that we've heard about 2-3 years ago now, about the alternative channel execution exploits, would be available much earlier. Now, whether it's a good or a bad thing, I don't know. In the spirit of open source, it's probably a good thing to know about this as early as possible and possibly close it, but you have to realize that it's still a business largely, and a lot of customers, even outside of Intel, AMD, Nvidia, Microsoft, etc., depend on the products of these companies. And so by doing that, you can actually hurt a lot of other companies. So you have to do your due diligence before you do this move. It's not like just let's open the software and that's it. We have to do a lot to make sure that it is open. Nvidia specifically is not, is embracing open sourcing actually. A lot of people for some reason think that PhysX, for example, is closed source, but it's all there on Git. You can download it, compile it yourself, and play with physics engines and understand how to build them. That's just one example of what is open sourced.
Okay, thank you. One more question? No? Okay. Okay, then I have one, just some philosophical one. Can some of you maybe describe what exactly you like in system programming or in your profession? I mean, I would really appreciate.
There are always problems that no one has solved before, and you got a chance to solve them first. So
yeah, so you go to Stack Overflow and find no answers, right? I mean, no question, no similar questions. You are the first.
Yes, I think it's more not like a development, but more like a research part when you need to solve some problem which in general, let's say, MP hard, but you need to provide a practical solution which will have, I don't know, analog and complexity in average. It's just an example.
Yeah, okay, so it's about discovery and research and finding new or creating new.
Yes, this field in computer science allows you to solve such problems.
Okay.
I think what excites me most about the system programming aspect of my job is the satisfaction that I get when I know that I was able to utilize the hardware most efficiently. Like one example I can give you on the Ansel project, I found that all existing PNG encoders, that's the image formats, were terribly inefficient in terms of speed, not in terms of compression. Now I needed a different trade-off. I needed them to be very fast, but maybe not as efficient in terms of compression. And so we've implemented multi-threaded AVXSSE optimized encoder that when you look at it with like VTune, for example, and you see that all the threads are 100% utilized, all the execution blocks in the CPU are 100% utilized, and that's on low level. But on the high level, you then see that actually you can store 4K PNG image on the disk like 10 times faster than the next contender. And that's the satisfaction that I can get with this aspect of my job that I really like.
Yeah, thank you. I can understand your passion. Yes, please pass the microphone.
Well, what I like is the variety, solving customer problems, of course, but we work across a number of different platforms. So we use FPGAs, we use AI engines, we use compilers, we generate code. So that variety really excites me, and that variety of things that we bring together in our tool is something that I really enjoy.
Great, thank you. Yeah,
Are you using Xilinx FPGAs?
Yeah,
that's the exciting point from me. So,
in fact, it's a place where people meet. Like that's why we do conferences.
Yeah, actually, the good thing about FPGAs, guys, is it's broad. Actually, it can be used in the high frequency tradings like vintage, where guys are earning money every milliseconds. It can be used in the medical. It can be used in education, in biological also. Currently, to get that metaflops or petaflops, engineers using parallel FPGAs, arrays of the FPGAs, and doing parallelly. Now, the frequency is just limited. We can just divide and split parallelly all the jobs and do it simultaneously and increase its efficiency. So. Yeah, the exciting point of FPGAs is like just having customers like Tesla, Synopsys, Siemens, all that stuff, Amazon, Alibaba, and such kind of. So very, very broad. So
yeah,
that's working with all those guys, customers, and it's getting experience talking with them and working with them.
Okay, great, thank you. Okay, thank you very much. Then that was my last question. If we have any, please come up. I guess we don't. Okay, thank you very much. I really appreciate the time that you brought. That was a pleasure to meet, and hopefully we will meet again on next System Programming Conference. Thank you.
Thanks.